So there's two basic tools that I'm going to talk about today that are sort of your back of the pocket, in your back pocket tools you can use that I think are good things to be maybe considering investing in and working with. One's a refractometer. We'll talk about that after lunch. And the other one's a conductivity meter. So I'll go into both of those today. I didn't talk about any real tools necessarily last course, which was last year. But soil conductivity, I think, is a really good metric to be aware of, and really an empowering sort of mode of interaction. So I always want to check soil conductivity in this hole before I plant. And if I do not have sufficient soil conductivity, I must do something about that. What is soil conductivity? Soil conductivity functionally is telling you how many nutrients are available to the plant right now. It's telling you how many ions are in solution. What it's telling you is how much food basically is flowing around. How many compounds are available in the soil matrix. So you can cheat soil conductivity. There's all kinds of things you can do with soil conductivity. But if you just get a meter and you stick it in the soil and nothing really been done there, that'll give you a good baseline on how much food, how much nutrition, how much energy is available for plants to grow with. This is a really, really powerful tool. And the effect is that you can actually see when your plants are getting hungry long before they get sick. And you can do something about it. It's really, really powerful. Or when they're getting thirsty. You can really use this tool very powerfully. So I always want to have a basic conductivity of about 150 in my soil. That's my baseline. And oftentimes you'll find if the soil was thawed out right now, it would be somewhere 20, 30, maybe 40. Oftentimes in spring soils, when you go to put your seeds in and put your seedlings in, it'll be somewhere between 30 and 50. That's been my experience pretty much across the board. Underneath the pollinating, a apple tree full of petals, flowers, wherever you go, you're going to find something along these lines. Yes.
Can you just explain the microsiemens, the millisiemens?
I was getting there.
Oh.
Yes. One of my problems is I don't understand I can't remember which one's which. Yes, it doesn't really matter. One's a big number, one's a small number. It's the same number. So there's So conductivity is measured technically, like we measure temperature in Fahrenheit and Celsius. We measure soil conductivity either in microsiemens or millisiemens. It doesn't really matter as far as I'm concerned. I'll just give you the short. So one of them is, the right answer is 150, and one of them is 0.15. And I'm sure there's somebody in this room who can tell us.
Yeah, micro is like...
Which one's a micro, which one's a milli.
So 150 would be micro, and then 0.15 would be the milli.
Siemens, like the company, Siemens. I guess he was a guy, right? Apparently Fahrenheit was a guy, and Richter was a guy, and Brix actually was a guy, right? Europeans, men, 1800s. Like all the scales we've got are named after these people who figured out some new, basic mode of assessment. Temperature affects conductivity because the way that conductivity occurs in the soil is through biological activity. When you've got biological activity, what that means is you've got life. So we think about bacteria, right? That should be billions and billions of bacteria in every teaspoon of soil. How long does a bacteria live for?
20 minutes.
Minutes to hours. So if you've got a couple billion people living in a teaspoon of soil, half an hour from now, you've got 500 million of them are dead. And their bodies are beginning to rot. And all their juices are actually all like, right? That's what the conductivity meter is picking up. Is their biodegrading body, all their protoplasm is food for the plant. That's the deal. The plant injects sugar into the soil, feeds these guys, they eat it, they reproduce, they go about their life, and they die, and then the plant sucks up their juice. To make it, really beautiful, nuanced system sound very simplistic. Something along these lines is what's going on. And so the colder the soil is, generally, the less biological activity is, and therefore the less functional nutrient availability there is. Yes?
Salts in relation to conductivity.
It's how you cheat to get a high reading. Right? That's why chemical fertilizer works. Chemical fertilizer is a salt. It's a simple, and then you add water, and it's a soluble nutrient. And boom, the conductivity goes up. Boom, your nutrient availability goes up. Unfortunately, you're getting, Doritos and Gatorade. right? And that's, so you certainly got lots of nutrition. It's of a very poor caliber. And if that's all you eat, then you're going to be really sickly, and your kids are going to be, can you say this?
In this room you can.
Your kids are going to be screwed up, right? I mean, you're going to, how do you get birth defects, and how do you get all the genetic diseases and things? This is how you get it, by eating poorly. And your DNA, we talked about this, I think, a little bit last time. We'll talk much more about it at the end of the day today. So anyway, that's why our plants need their herbicides and pesticides and fungicides, because they're so sick they can't stay alive without being constantly on the, chemotherapy or whatever. Anyway, conductivity is nutrient availability, and in most cases, especially in spring soils, you'll find nutrient availability is too low, which means if you put your seedlings in that ground, it's like taking your 5-year-old and saying, go out to school today with no lunch. So maintaining sufficient conductivity in the soil, for me, is massively important, and I'm really slapdash about most things I do. I am really not slapdash when it comes to putting my plants in the soil. I've got a pretty simple regimen and pretty simple protocol that I follow, and it generally is where I do most of my work. If I put my plants in well, there's very little I have to do between then and picking. Right? There's very little to do between then and picking. And really, I spend most of my time picking.